A bullet leaves a rifle with a muzzle velocity of 521 meters per second. While accelerating through the barrel of the rifle, the bullet moves a distance of 0.84 meters. Determine the acceleration of the bullet, and let's assume a uniform acceleration. How much time does it take to accelerate to this speed? So really there are two problems here. Determine acceleration, and then later on you need to determine time. Okay, so in this diagram of a rifle, you have a bullet, and what can we say about its velocity? Its velocity initial equals 0 meters per second. And the problem gives me a final velocity. So that's velocity final equals 521 meters per second. Gives me one more bit of information. It tells me that the distance from here to here is 0.840 meters. That's a distance. All right, these are my givens. Since we're talking about the x-axis, to be honest, I could be talking about the y-axis, but it's drawn in the x-axis. I'll use red. My velocity initial equals 0 meters per second. My distance in the x is 0.840 meters. And my velocity final equals 521 meters per second. Well, once again, I'm trying to solve two problems, so I'm going to divide my paper up. And if the first one, my unknown, is acceleration in the x, that's going to be in meters per second squared. And my second problem, my unknown, is going to be time. And that's going to be in seconds. The equation that I'm going to use for this first one needs to deal with velocity initial, distances, velocity finals, and accelerations. And so the equation that I'm going to use is velocity final squared equals velocity initial squared plus 2 times acceleration times distance. My velocity final is 521, I'm going to square it, equals 0 squared plus 2 times acceleration, which I don't know, times the distance 0.84. When I square 521, I get 271,441 equals, the 0 blows up, equals, and then when I take 2 and multiply by 0.84, I get 1.68 times the acceleration. In order to get acceleration all by itself, on the right-hand side, I'm going to divide by negative 1 point. I'm going to divide by 1.68. Whenever I do the right, I need to do the left. Acceleration equals 161572.02 meters per second squared. Now, if I sig fig this, I see that I have 3 sig figs here and 3 sig figs here. So the 1's significant, the 6 is significant, and the 1 is going to get rounded up to 2,000 meters per second squared. On my second problem, if I'm looking for time, the equation that I'm going to use is distance equals 1/2 velocity final plus velocity initial times time, which I don't know. When I replace numbers for letters, I get 0.84 equals velocity final is 521 plus 0 times time, which I don't know, times 2, or divided by 2. In order to simplify this side, I'll multiply by 2 to cancel. Whatever I do to the right, I have to do to the left. And I get 1.68 equals 521 t. I'm going to divide by 521 to cancel. Whatever I do to the right, I have to do to the left. T equals 0.00322245. And if I apply the correct number of significant figures, that's 3 sig figs, I get 0.00322 seconds.